Hello everyone, my name is Rakesh and today's topic is MP3 compression. One would obviously get the question, what is MP3? MP3 is an abbreviation of MPEG-1 audio layer 3. MPEG is itself an abbreviation of Moving Picture Experts Group. Then the next question one would have is why MP3? The MPEG-1 standard was concerned with techniques of compressing both video and audio. Specifically, it is layer 3 of MPEG-1 audio. Three layers of MPEG-1 audio coding were defined, each being more complex than its predecessor and each providing better results. That means if it supports layer 3 complexity, then it would also be supportable for layer 1 and layer 2 also. And next we will move on to how MP3 compression works. What makes MP3 encoding effective as a method of audio data compression is its deviation from the PCM model, where PCM model uses the analog to digital signal conversion. The fact of matter that our ears and our brain are imperfect and biased measuring devices which interpret external phenomena according to their own prejudices. Therefore, our goal is to reproduce a sound for the benefit of a human listener. Here what comes the perceptual coding. Moving on to the perceptual coding, it aims by referring to a psychoacoustic model to store only that data which is detectable by the human ear. This means this model works with the process of masking, which will take the steps regarding the removing of irrelevant data. Let us move on to the step 1 of our MP3 compression. The first stage of a process involves taking short sections from the original PCM stream and processing them with what's known as analyzing filters. The MP3 should be thought of not as a method of digital recording in its own right, but rather as a process for removing irrelevant data from an existing recording, as we said. The audio to be encoded will typically be 16-bit and sampling frequencies of 32 kHz, 44.1 kHz and 48 kHz are supported. And moving on to the process, typically MP3 encoders employ a variation of mathematical algorithms such as fast Fourier transformation and discrete cosine transformation to do the job for encoding. And the stage 2 involves the process of sub-band sections are grouped together into frames. The encoder examines the contents of these frames and attempts to determine where masking in both the frequency and time domains will occur and thus which frames can safely be allowed to distort. The encoder calculates what's known as a mask to noise ratio for each frame and uses this information in the final stage of the process, which is known as bit allocation. The final stage in the MP3 algorithm is bit allocation. During bit allocation, the encoder decides how many bits of data should be used to encode each frame. The more bits allowed, the more effective the encoding can be. The encoder therefore needs to allocate more bits to frames where little or no masking is likely to occur. When encoding is finished, all the frames are saved, each with some bytes of header data, and an MP3 file can be saved. Obviously, when we encode format, in order to retrieve the encoded format, we need to follow the decoding procedure. And what decoding does in this MP3 compression is, after resulting of the file which we want to encode, the file can then be read by an MP3 encoder and played as audio. An MP3 decoder performs a simplified reverse form of the encoding process. The sub-band frames are resynthesized into time domain sections and joined up to recreate an audio stream. Thank you.